I am Anil Kumar. Welcome to my series on transformation of functions. In this video, we'll take up some examples which will help you understand how to perform transformations on functions. We'll consider examples with vertical translation, horizontal translation, vertical stretch, compression, or reflection, horizontal stretch, compression, or reflection. We'll sketch graphs with all the combination of the above. We'll describe the transformations in an order so that they can be sketched. And then we'll graph transform functions. In general, a transform function is written as g of x is equal to a times f k of x minus p plus q. Now, if you have a transform function like this, in that case, the original points, let's say any original point on the graph P, x, y, is a point on the graph given to you, f of x, will have its image as the x value will be divided by k, and then p value will be added to it. As far as the y coordinate is concerned, it will be multiplied by a plus q. So that is the general formula for image of the points on the transform function. Now, keeping that in mind, let's now begin with the examples. So let us take example based on vertical translation. Now let us take our first example, which relates to vertical translation. We are given the function here, which is g of x is equal to f of x plus q. So whenever you have this kind of a function, q value is added to f of x. So if q is greater than 0, then the graph will move upwards. But if q is less than 0, then the graph will move downwards. So basically, there could only be a movement of the graph vertically up or vertically down. So that is what we mean by vertical translation. Now, in our example, 1, we have right transformation and graph the function y equals to x squared plus 2. So in this case, the q value is 2, more than 0. Since q is greater than 0, in this case, there will be a vertical translation by 2 units upwards, right? So that is how we are going to describe the transformation. Now, when a vertical transformation takes place, then every point on the graph will be actually moving upwards by 2 units. So we can take few critical points and move them by 2 units and sketch our graph. That's the whole idea, right? So we have these critical points. By connecting these points, we actually get our graph, right? So that is how you could quickly sketch the graph. So without even doing any calculations, this is the easiest way of sketching a graph. So we could sketch a parabola, and this parabola which we are sketching now represents y equals to x squared plus 2. So I hope this concept is absolutely clear. Now that is one way of doing it. The other way is you can find the image points. So the first step here is to write down all the points which are the key points. So we have the key points for y equals to x squared, and then we'll write down the image points. In this case, the image points corresponding will be p dash equals to x. That doesn't change, but y plus 2, y value changes. So we can now write down all these points. Let's copy the x values as such. The 5 key points, the x values being minus 2, minus 1, 0, 1, and 2. And then to get the y values, we will add 2. So 4 becomes 6, 1 becomes 3, 0 becomes 2, 1 becomes 3, 4 becomes 6. So these are the new coordinate points. You can plot these coordinate points and then join them. You get the idea. So these are the coordinate points which you can plot and get your graph. So that is the simplest way of sketching a transform function when there is a vertical translation. Clear? Now let's take another example. This one is based on horizontal translation. G of x is equals to f of x minus p. Now when that happens, the graph will move horizontally, left or right, depending on the value of p. So if the value of p is greater than 0, in that case we have x minus 2, x minus 3, something like this. It moves to right by p units, correct? But if p value is less than 0, you'll have plus here. In that case, it translates p units left. Is that clear to you? So that is how the transformation takes place. Now let's look into our example, which is right transformation and graph the function y equals to square root x plus 2. Now this is plus 2. That means the value of p is basically minus 2. That means that the graph of square root of x is translated 2 units left. Clear? Now, when that happens, then every key point, which will be pxy, the x value becomes 2 less. So the transformation will result into image point p dash, which will be x minus 2. Y values will remain the same. Perfect. So now, this time we are going to reduce the x values by 2. So instead of 0, we get minus 2. Here we get minus 1 and then 2. The y values will remain exactly the same. Is that clear to you? Now, another important criteria is to look into the end behavior. Here is a graph of square root of x. Now, in this case, you can clearly see that when x approaches infinity, y also approaches infinity. If you change this by 2 units left, that doesn't really matter much, right? Only in the case of reflections, it will change. Otherwise, with translations, this will not change. So the end behavior in this case remains exactly the same. So from the points, you can put these coordinate points here and sketch your graph. This is one way of doing it. Now here is alternate method. So one point is use image, right? The second is use graph. So in the graph, let's identify the critical points. One was at 0, 0. The other one is 1, 1. Then square root of 4 is 2. What we are really doing here is moving each 2 units left. What we are doing here is moving each 2 units left. So let's move these points 2 units left. So this point will come here. The other point will come to this position 2 units left, right? So this is 4. It will come to 2. So those are the new points. When you connect these points, we get our graph of square root of x plus 2. Does make sense to you? So that is how you could sketch it. Now, you could also check these points with what was identified. You'll find them to be exactly same. Perfect. So that is how you sketch the graph which has been translated left. Similar procedure can be used for even those which are translated right. Now let's take another case where we have a combination. So if you have a combination of horizontal and vertical translation, then you have to look in both the values. Perfect. So in this case, g of x is equals to f of x minus p plus q. That means there is a horizontal translation and there is a vertical translation. Example before us is write transformations and graph the function g of x equals to 1 over x plus 1 minus 2. Now clearly here we have two transformations. One is this, which is horizontal 1 unit, and then we have vertical 2 units down. So we can write down the transformations as 2 units up and 1 unit left. So that becomes the transformation of the function. You can actually describe horizontally translate the function 2 units down and 1 unit left. That is what you could do it. Now, 1 unit left corresponds to the change in x value. So that means the x value will be 1 less. 2 units down, sorry, not up, it is down. So let me erase this. Minus 2 will be y value will reduce by 2. Clear? So that is the transformation taking place. Now, whenever you're talking about a reciprocal function, this is a function which is 1 over x. In that case, critical parameter to check is the horizontal and the vertical asymptotes. So that is why in the key values, we have taken horizontal and vertical asymptotes. Now, each asymptote will shift as per the transformation of the function. So let us first see the vertical asymptote, which is the x value. So earlier, the vertical asymptote was at 0, x equals to 0, vertical asymptote. Now, this will be at x equals to minus 1. As far as the horizontal asymptote is concerned, it will be at y equals to minus 2, right? Substituting these values. So let's sketch these asymptotes first. So that is y equals to minus 2 graph. And then at x equals to minus 1, this will be our final graph. Correct? So we do get a graph with the asymptotes. Now, let's look into the points. The x values will be reduced by 1. So minus 1 becomes minus 2. The y value will be reduced by 2. So minus 1 becomes minus 3. The other values are minus half means minus 1.5, or we can write minus 1.5. Minus 2 and minus 2 is minus 4. 1 minus 1 is 0, and 1 minus 2 is minus 1, and 2 minus 1 is 1, and half minus 2 is 1.5, negative. So you get all your points, which are critical points in this particular case, to sketch your graph. So let's do them one by one. Now you can also see that minus 2 minus 3. So at minus 2, the value is minus 3, which is right there, right? Then minus 1.4, as you come closer, it is becoming minus 4 even more. So it is going to be right on that side. So we can see that the behavior of the graph is kind of like this, right? On the other hand, we have 0 minus 1. So at 0, it is minus 1. And at 1, it is minus 1.5. So it approaches in this fashion, correct? You can take some other values and you'll find that this goes kind of like this. So that becomes the graph of g of x. So you could sketch with the help of points as shown here. You could also sketch using these critical points. We are saying that each point will move. I copied this wrong. It is x plus 1, right? It is x plus 1. So each point here moves 1 unit left and 2 down. So if I consider this point, I am going 1 unit left, correct? Let me use another ink to show it. Moves 1 unit left and 2 down. Do you see that? And you get to your critical point. Perfect. Similarly, that is another critical point. Move 1 unit left and 2 down. You reach that point. Plus, we already have our asymptotes, and that should give you accurate graph. So I hope it makes sense. So using these points, original 1, 1, and minus 1, minus 1, you could get your final graph as shown. Perfect. So for a reciprocal function, let me remind you, the critical things to look into is 1, horizontal asymptote, and second, vertical asymptote, and third, you should check what happens to the point 1, 1 and minus 1, minus 1. That should give you accurate graph. The other points help you to check your values or the trend in a given case. I hope that makes sense, right? Let's move on and take the next example. So now we have vertical transformation. Let us see how do we incorporate vertical transformations while sketching a graph. The question here is example 4. Write transformations and graph the function y equals to minus 2x cubed. Minus means reflection on x-axis. So one we could write here reflection on x-axis. Correct? And the second is a vertical stretch by a factor of 2. So write vertical stretch by a factor of 2. So these are the two transformations which will take place on the given function, which is y equals to minus 2x cubed. Now because of this transformation, each point on the graph will now be, the y values will change, x value remains same. So x will remain same, y becomes minus 2 times the original y value. For a cubic function, these are your key points as discussed earlier in our video on parent functions. Now here, you will change all the y points, correct? X, y remains same. Multiply the y point by minus 2. So that is how you will write it. So 0 multiplied by anything is 0. So as far as 1 is concerned, that will become minus 2. Well, this value is wrong. It should have been minus 1 minus 1. So that becomes plus 2. Now the end behavior. If x is approaching minus infinity, y is approaching minus infinity. However, we have to multiply this by minus 2. And therefore, we can now write when x approaches minus infinity, y approaches plus infinity. Perfect. It reverses. Perfect. So when x approaches positive infinity, y will approach negative infinity. So that becomes the result. So this results into the opposite behavior. So the point which was here will now get to minus 1 plus 2. So this point will go to this point and 0 remains at 0. The point which was at 1, 1 will now be at 1 minus 2. Now joining these points and the end behavior we know about, we get our graph. Is that clear to you? Right? So we can now sketch the graph. All these points are getting reflected and they are being stretched vertically. So we have a graph which will be kind of like this. Do you see that? So that will become the graph which is vertically stretched by a factor of 2 and is reflected on the x-axis. So the end behavior reverses. That is kind of very important to understand. I hope the point is well taken. Now let's look into the next example, which is vertical transformation. Another example on vertical translation, example 5. Graph the function g of x, which is equal to 2 times f of x plus 1 for the given function. So the function is given to you, right? And here is your transformation. Let's write down the transformations first. So first we go for multiplication. So basically it is vertical stretch by a factor of 2 and translate 1 unit up. So translate 1 unit up. So these are the two transformations. The x value is not changing. So if we take up any original graph value as xy, the x value remains same. the y value gets multiplied by 2 and then we add 1 to it. Right. Now we have a graph here. Let's find the critical points. One of them is 0, 0. So let's take this point here, 0, 0. Okay. On this side, we have a point minus 2, 0. So I'm writing here minus 2, 0. Okay. Here we have a point which is minus 1, minus 1, minus 1, minus 1. And then we have 1, 1. And then we have 2, 0. Knowing about our transformations, we know that x values will remain exactly same. So without thinking, we should just copy these values. Now, to y values, multiply by 2, add 1. So we get 1 here. Minus 2 plus 1 is minus 1. 0 will give us 0 plus 1. 1 times 1, 2 plus 1 is 3. And 0 plus 1 is 1. So we get our new points. We can plot these points and get the final graph. So at minus 2, we now expect 1. At minus 1, we expect minus 1. At 0, we expect 1. At 1, we expect 3. And at 2, we expect 1. So we get a graph, as you can see very clearly. So that becomes your graph in this particular case. So now we can actually connect this to sketch. The other way to look into it is kind of like this. That plus 1 basically means that the graph moves 1 unit up. So this axis, instead of here, will now be at this place. The y values get multiplied by 2. So instead of going up by 1, they will now go by 2. So that is the whole idea, right? So here, 0 will be here, but it will go by 2. So that is how the graph will be, correct? So that is how it is going to go. You see that graph. So that is what you get. So I hope it is making sense to you. So you could actually now get back and check your results with the points. That's the good idea. So in a sinusoidal function, very key point is the axis. So whenever you're talking about sinusoidal function, look at the axis and the amplitude. That should help you to check your result. Let's take another example now. This time it is horizontal transformation for a function g of x. So horizontal transformation takes place when the inside value is multiplied by k. So whenever you have a horizontal transformation, in that case, we have a horizontal stretch or compression by a factor of 1 over k. That is very important to understand, right? And also, if k is, let me use another ring, if k is less than 0, then there is a reflection on y-axis. That is what could happen. Now, in our case, let's see what example we have. We are talking about g of x is f of 2x. So in this case, there is only one transformation, and we'll say because k is greater than 1, we have horizontal compression by a factor of 1 over 2, right? So it reduces, it compresses. So if you have to do directly from the graph, then 0 will remain at 0. The point which was at 2 will now come to 1. So these points will come closer. Do you see that point? Here, this was at minus 1. It will go halfway. And similarly, this graph will be like this. So what you get really is a graph which will be compressed, and that's what we mean. So this time period becomes half of the original time period. Perfect. So that is what we mean by horizontal compression. Now you could also identify the points. Let's say these are critical points for us: A, B, C, D. I am, um, let's call this C only. Okay, D, and this is E. So we can now write down these points where A on this graph is minus 2, 0, and B is 1, minus 1, minus 1. Okay. C in this case is 0, 0. D is 1, 1, and E is 2, 0. So when you do the transformation, it is f of 2x. So the x values get divided by 2. So we get x over 2. The y values remain same. That becomes the transform point. So for each point, we'll divide the x values by 2. So that becomes minus 1. This becomes minus half. That becomes 0. This becomes half. And that becomes 1. And the y values at these points will remain same. You see that? So that's the fastest way of doing it. You can confirm that they match with the points which you did on the graph. Now you need to do only one of these methods, and I actually prefer the graphical method since there is no calculations involved. So I hope that is making sense. Let's move on and take another example. So here we are combining the horizontal transformations, both stretches and translation. So what you see here is half x minus 1, right? So this k value is half and the p value is 1. So basically there are two transformations taking place. For the first one, which I am going to write, is horizontal stretch by a factor of 2. So reciprocal, right? And the second one is translate 1 unit right. Is that clear to you? So these are the two transformations. We could apply these transformations directly on the graph and then get our result. So let's do this. Let's stretch horizontally by a factor of 2. That basically means the point which was at minus 2 will become will go to minus 4. The point at 2 will go to 4, right? So they stretch. That is what we mean by horizontal stretch. The point which was at 1 will move to 2, right? So the new graph should be, I mean, this is one stage of this. The value at 0 remains at 0. And what we get here is this. And this is the graph of f of half x. So we are doing it in 2 steps. The other step is to move 1 unit to the right. So 1 unit to the right, when you apply to the given graph, what happens? Each point will shift now 1 unit to the right. So this comes here, this goes 1 unit to the right, so you get this part here, correct? This goes 1 unit right, so you go like this. This part goes 1 unit right, so you go here, and then 1 unit right, you land up there. So that becomes your final graph, and this is what is required. That is the g of x. Does make sense to you? So the new points are these, which are being marked in green. Now, you could actually write down the original points here and then work out the calculations. So the image point P will be the x values are getting multiplied by 2, and then we are adding 1, the y values remain same. Correct? So I like you to fill up these tables. So originally we had at minus 2, 0. Then we had minus 1, and then we had 0, 0. And then we had this graph at 1, 1. and finally we had 2, 0. So the values will be, the y values will remain same and the x values will change. So let me write down the y values, which is 0, 1, 0, 1, 0. Perfect. The x values we have to multiply by 2 and then add 1. So 2 times minus 2 is minus 4. Adding 1 will give you minus 3. 2 times minus 1 is minus 2, and then we get minus 1. And this will be 1. 2 times 1 is 2, 2 plus 1 is 3. 2 times 2, 4, and 1, 5. So that is your 5, 0. Do you see that point? This will be at 5, 0. And the first point here of your graph will be at minus 3, 0. That makes sense. Perfect. So that is how you're going to sketch this function. Now let us see what really happens when we do the transformation where multiple transformations are being applied at the same time. So example number 8, we have to graph g of x, which is equal to f of half of x minus 1 minus 1 for the function f of x equals to given to you. Now in this case, let us first write down the critical points. Last time we messed it up a bit. So this is better to write first. So the original points for us are minus 2, 0. Then we have minus 1, minus 1, 0, 0, 1, 1, and 2, 0. So these are our original points. Now, in these original points, we will apply the transformation. Transformation for us is now half of x. That is in a way, you should write in the standard form. So let me rewrite this. So we are saying g of x is equal to f of, take half common, right? So when you do that, you get x minus 2. So now you see horizontally translated 2 units to the right, not 1, right? So that is kind of important to understand. So we have minus 2. So the points will now get transformed. The x values will get multiplied by 2, right? And then add 2. The y values subtract 1. So we got y minus 1. That becomes the transformed point. So calculate your points. 2 times minus 2 is minus 4, plus 2 is minus 2. The x values will be minus 1 of 0. Now, 2 times minus 1 is minus 2, plus 2 will be 0. The y values, minus 1 is minus 2. 0 will give us 2 here, and 0 will give us minus 1 there. 1 means 2 plus 2, which is 4. The y value will be minus 1 with 1 will be 0. And then 2 times 2, 4 plus 2 is 6. So you do this math, right? 0 minus 1. You get your final points. Plot these points. Minus 2, minus 1. So minus 1 is right there. 0 minus 2. So at 0, you get a value which is minus 2. Then at 2, you get minus 1. So at 2, you get minus 1. At 4, you get 0. So at 4, you get 0. And at 6, you get minus 1. So at 6, you get minus 1 somewhere there. So you can connect these points and sketch your graph. So that becomes your result. Do you see that? So that is how you could connect. I hope it makes sense. You could also confirm this using transformation, right? But this is simpler in this particular case. So adopt any method. So apply any method. So your method could be consider image points when complicated. Complicated, I mean, when we have combination of transformations. Is that clear to you? But if it is a simple case, you can straight away sketch it from the graph. Now, we have a very interesting question. We are almost at the end. There are 10 questions in all. So here is your question number 9a. Now, in this question, describe the transformations in the correct order to sketch the graph of g of x equals to half of f half of x plus 1 minus 1. from the given function. So we are given the graph of the function itself. We have to sketch now the transform function. So let's list all the transformations required. So let's move from left to right. So list transformations, move from left to right. So the first one here, half, it represents what? It represents vertical compression by factor of 2, rather half, right? The second one, half inside, is a horizontal, but it is a stretch. It is reversing, right? Now, another important thing here is you may have to rewrite this to understand what is the horizontal translation. So let me rewrite g of x right there on the top. So we can write g of x as equal to half of f of factor out half, you get x plus 2 minus 1. Is that clear to you? So, so we get the second transformation, which is, sorry. So we get the second transformation, which is horizontal stretch by a factor of 2, 1 over half. And then third one here is translate 2 units left, and we're combining 1 down. Is that clear to you? So you can actually combine the transformations for translations. So that is how you could actually describe, right? So the question here is describe the transformations in the correct order. So when I say correct order means that multiplication first, right? So correct order means you have to do stretches, compressions, and reflections first. Correct? After that, you do translations, then translations. Then. Okay, now let's move on and take part B, where we are going to sketch this particular function. Part B is to sketch the graph of g of x equals to half of f, half of x plus 1 minus 1. Now, before sketching, let me rewrite this again as we did earlier. So we'll rewrite this as a function g of x equals to half of f of, we'll take half common, x plus 2. So if you don't do that, you'll make a mistake in horizontal translation. Does make sense to you? Now, we should identify the points. There are too many transformations. So the best way here is to identify the points. So we'll label them A, B, C, and D. Coordinates for point A are minus 2, 2. Coordinates of B are 0, minus 2. Coordinates for C, 2, 0. For D, it is 4, 6. Right. The transformation here is that each image point will, x values gets multiplied by 2 and translate 2 units left. For the y, we have to do half the y value and then take away 1. That is the transformation. So let's do the calculation. 2 times minus 2 is minus 2, take away minus 6 it becomes, right? The y value, half of 2 is 1, 1 minus 1 is 0. So that is the A dash. The next point, 0 minus 2 is minus 2, half of minus 2 is minus 1, minus 2 here, and that is your B dash. 2 times 2 is 4, 4 minus 2 is 2, 0 minus 1 is minus 1, that is C dash. 4 times 2 is 8. 8 minus 2 is 6. 6 half is 3. 3 minus 2. 3 minus 1 is 2. So that is d dash. So we get these points. Let's plot these points. Let me use a different ink to plot them. So A, B, C, D is minus 6, 0. So minus 6, 0 comes there. Minus 2, minus 2, second point. 2 and minus 1, 2 and minus 1 here. And we have 6 and 2, 6 and 2. So those are new points. We'll connect them. That's it. So these are your image points A dash, B dash, C dash, and D dash. And that is how you're going to sketch it. So whenever we have more than one transformation, right? So combination, apply image points. Is that clear to you, right? So that is very important. The last question here. Describe the transformations in the correct order to sketch the graph of the given function. The transformations minus, that means there is a vertical reflection, f of half x minus 1 minus 1. So let's write down these transformations. So the very first one here is the reflection on x-axis. The second one is horizontal, let me write in short, horizontal stretch by factor of 2. And then translate 1 unit right, 1 right. Translate 1 down. So those are your transformations. Clear? Have a good look at it. So now it says describe the transformation in the correct order. That is the correct order. That means multiplication first. Think like this. Right. So after that you do translation, right? That is the order. So order of operation is being followed. So you have to begin with reflection. So that is the graph. So when you want to reflect it, let me use different colors and show one by one. So that point comes here, and this point, which is at 1, it goes to that. So they change your position. Does it make sense to you? Right? So that is how it is going to change. The points which are at the center, they remain there. So what we get here is a graph which will be kind of like this. So this is your minus f of x. So that is the first part taken care of. Now let's use the other ink for horizontal compression. No, rather stretch. So stretch means the point which was at 2, it will go to 4, right? Minus 2 will go to minus 4. So they are stretching. Here at minus 1, it will come to this place. 0 remains at 0. And that is the stretch factor. So you get a graph which is kind of like this. So the green graph which I am drawing now is minus of f of half x. Perfect. Now we are going to translate 1 unit to the right. So let me use another ink to translate 1 unit to the right. So each point will shift 1 unit right. So let's go along and see we just moved it 1 unit right. So this graph which I have drawn now is minus f of half x minus 1. Now what are you left with? Minus 1. So the final graph I'm drawing in red will be 1 unit down from the blue one. So we bring this point 1 unit down, this point also 1 unit down, this point also 1 unit down. So what we get here is this. and these points 1 unit down, that point 1 unit down. So not very difficult. So finally, we got our function g of x as minus half of x minus 1 minus 1. So we did all the steps one by one. So the first step here, let me write down, show you. This is our first step, right? So let's say this is step number one. Step number one is the reflection, which is shown here. Then we have step number two, which is shown in green. Then we have translation, 1 unit to the right, which is shown in blue. And the final step shown in 4. You get your final graph. Does it make sense to you? So I hope with this you understand exactly how to sketch transform functions. So we actually went through all these examples. Now we know if we have vertical translations, then we should adapt direct graph. Correct? We should do this even if we have horizontal translations alone. But if we have these combinations, it is good to find the image points. Correct? So that is kind of important to understand. However, you understand that steps to sketch with the help of graph is not bad. Since the last example which we did was not really bad. So you could show all the steps. The advantage here is no calculations required. So that's the beauty of it. So I hope with this you get a good picture of how to sketch transform functions. I'd like you to now attempt the test paper on the transformations and try to do the last few questions which require a lot of details, especially from question number 13 to question number 22. That will give you good practice. I hope you enjoyed as much as I enjoyed delivering this lecture. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'll be great. Thanks for your time and all the best. Thank you.